Have you ever wondered what would actually happen if you fell into a black hole? I mean, it's one of the craziest questions in all of science, right? A one-way ticket to the very edge of reality. Well, today we're taking that trip. We're going to explore what's hiding inside these incredible cosmic mysteries. So let's dive in.
This really is the ultimate what if, isn't it? A journey with no return trip into the absolute unknown. What would you feel? What would you see? That's exactly what we're going to break down step by agonizing step.
Okay, but before we take that imaginary plunge, we got to back up for a second. We need to be absolutely clear on what we're dealing with. So let's start with the basics. What even is a black hole? So this is the fundamental idea, and it all goes back to Einstein. A black hole isn't really an object in the way we think of one. It's a place where gravity has become so powerful it has literally broken the fabric of space and time. To escape, you'd have to go faster than light. And since that's the universe's ultimate speed limit, well, nothing gets out. Period. So where do these cosmic monsters come from? Well, the most common ones are basically giant stellar tombstones. You take a star, one that's way, way bigger than our sun, and when it runs out of fuel, its own gravity just takes over. The core collapses in on itself with such force that it crushes down into a point of almost unbelievable density.
All right, with the basics down, our journey can really begin. I want you to picture yourself in a spaceship. You're slowly inching closer to one of these gravitational behemoths. From here on out, things get seriously weird.
And you know, our approach isn't just a straight shot. We've got to get through three very distinct and increasingly bizarre zones. Think of them like the outer layers of the storm, each one with its own set of absolutely wild physics.
You see, the chaos outside a black hole can be just as intense as whatever's inside. First, you hit the accretion disk. This thing is a swirling vortex of gas, dust, and shredded stars, all heated to millions of degrees and blasting out X-rays. Get closer and you might find the photon sphere. Now this is wild. It's a place where gravity is so perfectly tuned that light itself can get trapped in orbit. And just to top it off, some black holes launch these massive jets of plasma out into space at nearly the speed of light. Okay, we've navigated through that cosmic light show, we've survived the chaos, and now we are right at the edge of the most famous boundary in all of physics. This is it, the event horizon.
But wait, before you even cross that final line, your journey takes a pretty painful turn. As you get closer, the black hole's gravity starts to pull on your body in a very specific and, let's just say, very unpleasant way. Physicists have a truly fantastic name for it.
And yep, that pretty much says it all. The physics here is brutal. The gravitational pull on your feet would be so much stronger than the pull on your head that you'd literally be stretched longer and thinner, just like a piece of spaghetti. It is, no joke, the universe's most extreme stretching machine.
And as if being turned into cosmic pasta wasn't enough, it's not just space that gets all twisted up here, it's time too. There's this concept called gravitational time dilation. The closer you get to that immense gravity, time for you actually starts to slow down. Your watch would literally tick slower than the watch of someone watching you from a safe distance.
And that leads to this completely bizarre paradox. For you, the person falling in, the moment you cross the event horizon might feel, well, totally normal. No bells, no whistles. But for your friend, watching from their spaceship far away, they would see you slow down, get dimmer, and seem to freeze right at the edge, forever. From their point of view, you never, ever actually fall in.
Okay, we've done it. We've crossed the boundary. There's no turning back now. And from this point on, we have to leave the world of what we can observe and enter the world of pure theory, where our known laws of physics they start to break down.
So once you're inside that event horizon, the rules of the game change completely. Space-time is so warped that moving forward in time and moving toward the center become the exact same thing. It doesn't matter which way you turn your spaceship, every possible path now leads to one inevitable destination, the very center.
And that destination is the singularity. According to Einstein's general relativity, it's a point with zero size and infinite density. But here's the thing. Whenever physicists see the word infinity pop up in an equation, it's a giant red flag. It's a sign that the theory has stopped working. It's basically the universe telling us, nope, you're missing a piece of the puzzle.
And this is where the two great pillars of modern physics just slam into each other. You've got general relativity, our theory for gravity and all the really big stuff, predicting this perfect infinite point. But then you have quantum mechanics, our theory for particles and all the really tiny stuff, and it basically says, no way. That's impossible. Finding a single theory that can unite them and tell us what's really going on, well, that's the biggest question in physics today.
Quantum mechanics also throws another wrench in the works. It suggests that black holes aren't perfectly black after all. A process called Hawking radiation lets them leak a tiny bit of energy. Over unimaginable amounts of time, this means they can actually evaporate and disappear completely. But that creates a huge puzzle. If the black hole vanishes, what happened to the information about everything that fell in? Physics says information can't be destroyed. So where does it go?
Now, I know this all sounds like super abstract, out there theory, but black holes are very, very real, and we've gotten incredibly clever at finding them. So the question is, how do you see something that by its very definition is completely invisible?
Well, you look for the chaos they leave in their wake. It's like being a detective at a crime scene. We can track a star that seems to be orbiting, well, nothing. We can spot those intense X-rays blasting from superheated gas as it gets devoured. And amazingly, since 2015, we can even hear the ripples in space-time itself, these things called gravitational waves, that are created when two black holes smash into each other.
And when you look at the timeline, our journey of discovery is just remarkable. It all started as a mathematical quirk in Einstein's theory over 100 years ago. Then, we actually detected the echoes of their collisions. And then came the greatest leap of all.
In 2019, the Event Horizon Telescope collaboration showed the world this. Now, this isn't a picture of the black hole itself. That's impossible. What you're seeing is its shadow, the silhouette it casts against all that glowing, superheated gas swirling around it. For the very first time, humanity had actually seen the unseeable.
Which really brings us to the final big idea. Black holes are so much more than just cosmic vacuum cleaners. They are nature's ultimate laboratories. They push our understanding of physics to its absolute breaking point. And by trying to understand them, we might just find the keys to the most fundamental laws of space, time, and maybe even the entire universe.